Have you ever sat by a nice, cozy fireplace and just wondered how much of that amazing heat is actually just going up in smoke? Well, today we're going to dive into a really ingenious solution that started out as just a simple idea in a notebook. It's all about reclaiming that lost warmth and making our homes way more efficient. So let's break it down. Right, think about it. You're sitting by the fire, you feel that wonderful warmth on your face. But here's the crazy part. Up to 90%, that's 90, of the heat your fire is cranking out is actually lost. It just goes straight up the chimney. That's a ton of wasted energy. So what if we could actually trap that heat and use it?
And this is exactly where the solution begins. We're about to look at the very first sketch, that aha moment, where an idea starts to take shape. This is the seed of a concept for grabbing all that wasted heat and putting it back to work.
Okay, so check this out. The beauty of this first drawing is just how simple it is. The core idea? Intercept the hot exhaust before it can escape. You see how the smoke gets routed through that series of coiled copper tubes? Then it's surrounded by these heat-reflecting walls, which basically act like mirrors, bouncing all that radiant energy right back onto the tubes to get them super, super hot. But, a great concept is really just the start. The next and absolutely crucial step was to turn this drawing into something that was practical, something you could actually build and install in a real home. And this sketch shows that evolution perfectly. The whole design is now built on this sturdy, modular steel wireframe. You see how these exhaust modules can be stacked one on top of the other? This is the key insight right here. It makes the entire system totally customizable for different chimney heights. It's not just a cool idea anymore. It's an engineered, flexible solution that has to be structurally sound. So let's do a quick teardown of the key parts that make this whole thing work. The backbone is the steel wireframe, giving it all its structure. Everything fits into that frame thanks to the modular design. Now, the real magic, the heat transfer, happens in those copper tubes, and they're all connected by couplers. You've got mounting brackets to keep it all secure inside the chimney. And you still have those heat-reflecting walls, but now with a game-changing addition, a low-power fan to actively move the warm air around. Okay, so we've seen all the individual parts, but how do they all come together to actually heat your room? Let's follow the journey of that heat from the moment it leaves the fire right back into your living space. It's really a beautiful, efficient four-step process. First, hot smoke billows up into the copper coils. Second, those tubes start radiating an immense amount of heat, which gets concentrated by those reflective walls. Third, that little low-power fan kicks in, pulling cooler air from your room and pushing it across those superheated tubes, kind of like how a radiator in a car works. And finally, that freshly warmed air gets vented directly back into your living space. Simple, elegant heat exchange. But this inventor didn't stop at just capturing heat. The design kept evolving to tackle another big problem: pollution. A whole new module was added with a really ambitious, environmentally conscious goal to actually clean the smoke before it ever leaves the chimney. And this final schematic shows that smoke reduction module right at the very top of the whole system. There's now what's called a smoke condensation chamber. The big idea here is to essentially wash the smoke, pulling out soot and other particulates to make the emissions a whole lot cleaner. So how does this clever cleaning process work? Well, it's 4 main stages. First, smoke gets pulled into the chamber. Second, a humidifier sprays a really fine mist, which makes all the little soot and dust particles heavy with water. Third, and this is the really ingenious part, they pass by these electrically charged plates that attract and snatch those wet particles right out of the air. And finally, cleaner smoke is released, while all that dirty water just drips down into a collection tray below. To put it really simply, just think about when you were a kid and you rubbed a balloon on your hair and then stuck it to the wall. That's static electricity. These plates use that exact same principle. The static charge creates this electrical attraction that's strong enough to pull the wet, heavy soot particles right out of the air. It's like a powerful magnet for pollution. And just think, this entire complex system, from a simple heat trap to a modular frame and even an air purifier, it all started with a pen and a sketchbook. It's just a powerful reminder that solving a common everyday problem can lead to some truly incredible innovation. It really makes you look around and wonder, what's the next great idea for our homes hiding in a simple sketch?